So where do these things come from? All right. The development of these cells is a process called erythropoiesis. In general, all of the blood cells, white and red, is called hematopoiesis, but these are erythrocytes or RBCs, so I'm going to call this process erythropoiesis. You're going to start with, as you do in every case for cell development, a stem cell. All right? And the stem cell that typically leads to the committed cell series to make RBCs is called a hemocytoblast. You will never have to ID a hemocytoblast. In fact, you'll never have to ID even the next step along that chain. All right? Matter of fact, in this block, you won't have to ID any of these. All right? But it will come later. All right. Actually, at the very end of the year, there's going to be a block where you're going to have to learn this series and ID them. Right now, I'm really concerned with you learning how they develop rather than IDing them in lab. So you won't ID them in lab yet, but you do need to learn the process of how they develop because it's important in their function. So you start with this stem cell. This is the stem cell that can get all of the different blood cells, all right, the hemocytoblast. And depending on which cofactors, all right, it's hit with, mostly hormone factors, that depends on which cell line it's going to develop into. So in this case, it gets hit with something called erythropoietin. And that is going to make it go down the cell path, all right, to produce the erythrocytes or RBCs, all right? All right. So once it gets hit with that factor, it develops into this cell called a proerythroblast. This is a pretty big cell, all right? Where do you see these things? Typically, red bone marrow. Some of this process can occur in things like the liver or even the spleen, but those are typically events that you might see in fetal development. Usually in postnatal development, almost all of the erythropoiesis, in fact all of the blood cell development, white and red, is occurring in the bone marrow. Okay, so you're going to start thinking of this as a process that occurs in the bone marrow and then gets released into the blood here down at the end of the line. All right. So this proerythroblast in the bone marrow is a pretty big cell, all right? And that's going to always, it's basically the committed cell. It can't go into any of the other cell lines. It can't back up and take a different path. It's committed to going down that path at this point, okay? It's a big cell, and it has a deep blue cytoplasm, right? And it has a deep blue cytoplasm because it has a lot of RER. Right, and the typical stains we use show that nucleic acid in the RER as dark blue. All right. So what happens next? It starts to make a lot of protein. What is it making? Everybody ought to know the answer to this question. What's it making a lot of? Hemoglobin, right? Okay, so as it develops, it becomes slightly smaller and even darker cytoplasm, all right? And this one is so dark blue that we call it a basophilic. Basophilic means it takes on a basic stain. And we're going to talk about this in lab today, if you have lab today or tomorrow. What is basophilia and what is eosinophilia? Don't worry, it's coming in lab, okay? But this is dark blue color here in the cytoplasm is the result of all of that RER in the cytoplasm and all of that protein production machinery sitting there, starting to churn out. So as it makes more and more hemoglobin, guess what happens? You get a change in color. All right, and that change in color is due to the presence of all that hemoglobin beginning to build up in the cytoplasm. Proteins tend to look kind of pinkish in a typical stain. All right, we call that eosinophilia, right? So You get a little bit of a change as these things develop and make more and more hemoglobin. They have more than one color in the cytoplasm, so we call them polychromatic, okay? So here the cytoplasm has a mixture. Sometimes it's patches of blue and patches of pink. Sometimes it's this funny kind of gray mixed color. Just depends on the cell, all right? So that's a polychromatic. That's the next step along the pathway. What else is going on as we make the hemoglobin? Well, this nucleus is going to get smaller and smaller and smaller and darker and denser as you go down the series. Why? It's being shut down. It's going to get completely shut down and inactivated. All right? So as you go down this series, it gets darker and darker to almost a purplish black look, and then it gets ejected out of the cell. Here you're seeing the ejection phase. Some people we'd like to eject, right? I know. I won't mention anything political, believe me. All right. All right. So we've gotten to polychromatic erythroblasts. So what happens next? The next step in the process is you've made so much hemoglobin that the cytoplasm looks completely pink, basically the exact same color as the mature erythrocyte. Here it's shown in a dark red, but you know, typically when you're looking in bone marrow and you see those almost mature ones that are ready to be released from the bone marrow,